All right, we're going to look at one more example of solving a proportion with factoring. And this time we're going to have a more difficult scenario. So this is actually question number 6 from content check 2.3/1 on the A side. So let's take a look. Right now I can see already I'm going to end up with factoring because I have two binomial expressions that are diagonally across from each other. So we're going to go ahead and find our cross products. So on one side, we'll do 5 times 3. And on the other side of our equation, we're going to multiply 2x minus 1 and x plus 3. Okay, so 5 times 3 we know is 15. And now to get 2x minus 1 times x plus 3, we're going to actually have to multiply those. In the last example, I showed you guys the area model. In this example, I'm going to FOIL it for the FOILers out there. So you can still use the area model. You'll get the same thing. If you're used to FOILing, you learned that FOIL stands for first, outer, inner, last. And it's just a way of making sure you distribute each term appropriately. So the first two terms are 2 times x, and that's 2x squared when we multiply. The outer terms, 2x times positive 3, we get 6x. The inner terms, negative 1 times x is negative 1x. And then the last two terms, negative 1 times 3 is negative 3. So no matter if you use the area model or FOIL, we should get the same, we get the same information in our polynomial, and then we want to simplify it so that those two linear terms in the middle become 5x. So 15 equals 2x squared. We said 6x minus 1x is 5x, so plus 5x minus 3. Okay, now just like in the example before, we need this to be set equal to 0. So we're going to subtract 15 from both sides. So now 0 equals 2x squared plus 5x. Negative 3 minus 15 is negative 18, so minus 18. Okay, so now if you're wondering why this example is more difficult than the last one, it's because of that number 2. That pesky number 2 right there means we're going to have to factor by grouping. So we're going to start our factoring problems off the same way. We're going to look at this in standard form, and we're going to find the product of a times c and put that in one part of our x at the top. We're going to put our b value in the middle. And again, remember, in standard form, a is the coefficient of x squared, b the coefficient of x, and c the constant. So a times c is 2 times negative 18, which is negative 36. So we just multiply those two numbers together. B in the middle is 5. Okay, so now we're looking for two numbers that multiply to negative 36 and add to positive 5. And if you think about the sign, if their product is negative, we know one of these numbers must be positive and the other must be negative. So we're now thinking of two numbers that multiply to negative 36, whose sum is 5. So I would think about the factors of 36. We can rule out 6 and 6, 36 and 1, 2 and 18. But eventually, you should come to 9 and 4. So a positive 9 and a negative 4 would multiply to negative 36 and add to a positive 5. Those are the numbers we want. All right, so this is the step where it's no longer like the last example. We can't just go straight to factoring, but instead, we can take this middle term, 5x, and expand it. So we're going to have 2x squared, and we're going to use 9x and negative 4x in place of 5x. My advice to you is if one of these is negative, put the negative first. That'll help you with some sign problems you could run into. So minus 4x plus 9x, and then this minus 18 stays the same. So all that work just to turn 5x into negative 4x and positive 9x. All right, now we're going to put parentheses around these two binomials. We leave the plus sign in the middle. That always needs to be a plus sign right there. And now we're going to factor out the greatest common factor one at a time. So the greatest common factor of 2x squared minus 4x. Well, I know 2 is the GCF of 2 and 4. X is the GCF of x and x squared. And we're left with x minus 2. So when we divide this, we're left with x minus 2. All right, so come over here, factor. 9 is a GCF of 9x minus 18. So we pull a 9 out. We're left with x minus 2 in parentheses. So we divide everything in here by 9. So remember, these always have to be the same expression. If they're not, you've made a mistake. So we should have x minus 2 in both sets of parentheses. All right, almost at the last step. I know these are long problems. Everything on the outside, so the 2x plus 9, it's like we're undistributing x minus 2 to 2x plus 9. So I'm going to take 2x plus 9 and put that in one pair of parentheses, and then x minus 2 in the other. So we're just reversing the distributive property when we do that. Now we're at the last steps, plural. We could set each of these equal to 0. That's our zero product property. So 2x plus 9 equals 0. Subtract 9 from both sides. 2x is negative 9. Divide by 2. X is equal to negative 9 halves, which is the same as negative 4 1/2, or 4.5. Do the same with x minus 2. Set that equal to 0. That one's easy. We just add 2 to both sides. X equals 2. So these are our two solutions, x equals 2 and x equals negative 9 halves. Now, if you're really struggling with factoring, you can use the graphing calculator on this problem. So if you go back to where we first set this equal to 0, let's look at that in the calculator. We're going to go into y equals, clear out whatever's in there, put in 2x squared plus 5x minus 18. Let's just see what this looks like. We might have to change our window. As long as it crosses, that'll work. All right, so our solutions are going to be these two places the parabola crosses the x-axis. So we could go to second trace, 0, because we said we call them roots, we call them zeros, we call them x-intercepts. I don't know why we have 3 names for them. It's going to ask you for a left bound, so we're going to go left of where that crosses. Then we're going to move right of it, and then we're going to go back and guess where we think it is. The calculator tells us that that 0 is where x equals 2, and that's one of our solutions. So if we did this correctly, this other 0 should be at negative 4 1/2. We never just want to use trace to approximate it. We always want to attend to precision and use 0. All right, so left bound, right bound, guess. There we go, negative 4 1/2.